All right, so for LT7, we are focusing on um, living things at the atomic level. So we're going to talk about the most abundant elements in living things and also why carbon is so important for building larger macromolecules. So, first of all, you can probably off the top of your head list some of the four most abundant elements in living things. So, of course, the one that we're going to talk about today is carbon. Next is oxygen, obviously very important, hydrogen, and nitrogen. So, just to give kind of an idea of why we are talking specifically about carbon, is because the image that comes to my mind when I think of this is a skyscraper that is being constructed, right? So there's people working on it, but when you see a skyscraper being constructed, you at first see kind of this steel box outline skeleton type thing, right? And it's mostly open space, but you see the kind of framework that the steel is making. And so we can kind of think about carbon in the same way, right? Carbon is that molecule that serves as kind of the backbone or the skeleton or the framework on which we can build more complex molecules like proteins, amino acids, polysaccharides, things like that. Now, oxygen also plays a very important role in especially your metabolism. So, taking food and breaking it down and turning it into energy and those sorts of things. Hydrogen is the most abundant element in the universe. I think like 70% of all atoms are hydrogen. So, why not have them be mostly in your body as well? And then nitrogen is especially important for proteins. So, you guys already made a model of carbon, and that should have revealed some things about it, right? If you remember correctly, carbon had 6 protons, 6 neutrons, and 6 electrons, but 4 of those electrons were on the outside, and 2 of those electrons were on the inside. So in other words, carbon had 4 valence electrons. And this actually directly leads to it being useful for us in a biological context. So, the chemistry of carbon. Most matter in your body is made up of organic compounds. Now, what we mean by organic compounds are compounds or molecules that are made out of these 4 elements, right? Like carbon, hydrogen, nitrogen, oxygen. You can also throw in phosphorus and sulfur and these sorts of things. So, carbon is important because it forms the backbone of these molecules. It forms that inner structure that allows them to exist. So, why is this the case? Well, first of all, carbon has 4 valence electrons, which means that it forms 4 bonds. Remember the octet rule? Atoms really would like to have 8 valence electrons, and it's going to form bonds in order to increase the number of valence electrons that it has. Okay, so if carbon has 4 valence electrons, that means it has 4 open spaces that it needs to fill. Therefore, it'll form 4 bonds. Now, that is a rule, pretty much that is gospel truth, right? If you see carbon and it doesn't have 4 bonds, then it's wrong. Okay, someone drew it wrong, for the most part. Okay, carbon, whenever you see it, and I'll point some out here later, but it's always going to have 4 bonds. Now, these bonds are covalent bonds, meaning that electrons are shared between atoms. And these strong covalent bonds are what allow us to build long and bigger molecules. Okay? Now, carbon atoms can also bond to each other, right? These are known as double bonds, triple bonds, even single bonds. So whenever an atom forms a covalent bond, it's going to be sharing a pair of electrons with another atom. So in a single bond, it's sharing 2 electrons with another atom. In a double bond, it's going to share 4 electrons with another atom. And then with a triple bond, it'll share 6 electrons with another atom. Now, these carbon atoms can be built together to form chains, but they can also close up to form rings or like ring shapes. And so these are actually where carbon is the most stable. If I have a chain of carbon, especially if it's single bonded, okay, it's going to be most stable in a ring. And so you're going to see a lot of molecules that have these sorts of carbon ring structures to them. So carbon's important because no other element comes close to matching its versatility. And the reason why it has this versatility is because of these four reasons here. Oh, sorry. Everything comes by twice. Here we go. So here's some examples, right? This is a simple molecule. This is methane, okay? It is carbon bonded to 4 hydrogens. These lines here indicate a bond, okay? And since there's only one bond, this is a single bond. But notice that carbon is able to make 4 bonds: a bond to the right, a bond to the left, a bond up, and a bond below. Okay, and this makes carbon kind of a good corner piece. Okay, let me give you an example here of what I mean by corner piece. Right, if you've ever played with magnetics, okay, what makes magnetics interesting is that you have all of these bars, right? But they are joined by these metal balls. And so imagine that these metal balls are carbon, right? Because carbon is able to join all of these different things together. It serves as kind of the hub that centralizes the rest of these pieces, right? And carbon is able to do that. Carbon is able to do those things because it can make 4 bonds. Here's another example of carbon. Okay, this is carbon dioxide. This is what you breathe out. And so here we've got a carbon in the middle. It's got 2 oxygens that it's bonded to, but notice how many bonds carbon has. Carbon has 4 bonds. 1, 2, 3, 4. And so each of these dashed lines represents a bond, and each of the dashed lines also represents 2 electrons that are being shared. You kind of see a different version of it up here, right? Here's a bond because they're sharing 2 electrons. Here's a bond because they're sharing 2 electrons. Here's a bond. Here's a bond. Here's an example of a triple bonded carbon. This is carbon monoxide. Now this is one of the rare occasions where carbon only has 3 bonds, okay? That is a very rare occasion. Like, this is the only one that I know of off the top of my head. There's more that exist, obviously, but this is the only one I know off the top of my head, okay? But that is a triple bond. It's sharing 2 electrons here, 2 electrons here, 2 electrons here. Now, here's what I meant when I said that carbon kind of serves as the framework, right? Because we have this chain of carbon that's closed into a ring, and then we've got kind of stuff hanging off of it, right? And it's kind of the stuff hanging off of it that gives this whole molecule its purpose or its function. So this happens to be glucose. This is the sugar molecule glucose. It's made up of a 6-carbon ring. Okay, 1, 2, 3, 4, 5, 6 carbons. That is it for chemistry of carbon. Go ahead and use what I've told you here to fill in your notes, and I hope that was helpful.